Hello, today we are going to see extending the transition function to the string. Already we know that what is transition function while we are studying finite automata. Now, when we explain formally that DFA, that is deterministic finite automata, defines a language which is nothing but a set of all string that results in a sequence of state transitions from the start state to the accepting state. In terms of transition diagram, the language of a DFA is a set of all labels along all the paths that leads from start state to the any accepting state. So now what is delta transition function? In the terms of transition diagram, the language of DFA is a set of labels along all the paths that lead from start state to any state, as we said. Now what is extended transition function? It is a function that takes state Q and string W and returns new state P. The state that the automaton reaches when starting in the state Q and processing the sequence of input W. Here remember the thing is that we are saying sequence of inputs, that is string A. Normally transition function is what? At a particular state, after reading input alphabet set, we are going to the new state. But extended transition function talk about the state of automaton that reaches starting in the state Q and processing the sequence of input. Already some part of the string is already processed. Now I wanted to know after reading the last symbol of that state what will be the next string. So initially suppose sometime I say string read, that string may be an empty string. So what will be the new state? You will be in the same state. So delta transition function Q epsilon is equal to Q. That is, if we are in a state Q and read no inputs, that means empty string, then we are still in the state Q. Suppose now normally any string of any length we can say, it is not an empty string. Then what will be the extended function? So suppose W is a string of the form XA, that means A is the last symbol of W and X is a string consisting of all but the last symbol. So delta transition function for Q that W is equal to extended function of transition function Qx for A. This is the way to calculate the extended transition function. To compute transition function, or I say extended transition function QW, how to do that? First, compute extended function over at a state Q after reading symbol X. Here it is not a symbol, it is a string actually. The state, that is the automaton, is in the after processing all the but last symbol of a W. I can say string W minus 1, because that minus 1 is what the last symbol we are going to read here. So till that whatever the part of the string is read is the X. So first we need to compute till that point what is the state. Now we are in that state say P. So afterward reading that last symbol, extended function Qx is equal to P. Right? Then the transition function QW is that we get by making the transitions from state P on input A. That means input A is the last symbol of a string W. So now what is the next step? I can say in the other word, delta transition QW is equal to transition function of PA. What is W? It is nothing but XA. So we know that till X we were in the state P. So now after reading the last symbol of a W, that is A, what will be the next state? That we are going to find out, or directly we can find out after reading portion of the string with the help of extended transition function. Let's say example, take one example. There is one language consisting of a string such that every string has both even number of ones and odd number of zeros. Sorry, even number of zeros and even number of ones. So now state used to remember what the number of zeros seen so far is even or odd, and also to remember whether the number of ones seen so far is even or odd. We have to remember both zeros and ones, either odd or even. So what are the interpretation while calculating the delta transition function? How we will do that? How many states are there? Prior to that, we should know how many states are there in the finite automata. What are the states? So interpretations are like this. There are first state. We have to find out first state. It is a starting state. Both the that means initially both the number of zeros seen so far and the number of ones seen so far are even, because both are zero. Zero is a even. We already seen that. Now after now in the first state I may read either 0 or 1. So according to that we have to change the state, because that will be the first occurrence of odd number, right? Which is need to be remembered, because our focus is on the even number of ones. The number of zeros seen so far is even, because zero number of ones, but number of ones seen so far are odd. Initially I was in the first state Q0, now I see 1. So number of ones are odd. We have to remember that. Change the state to the Q1. But their number of zeros are even and number of ones are odd. Now reverse case. Suppose the number of ones in so far is even. One more I read. Now I was in the Q1. I read one more one. So now I will see 2 ones. That is what even number of ones. But the number of seen so far is odd. That is another case. One more interpretation, both number of zeros seen so far and the number of ones seen so far are odd. So these many possibilities are there while solving this example. Now state Q is both start state and alone the accepting state. In this case, why? Now we have to decide next part of the while designing the DFA. We decided the transition. Next part is deciding start state and the end state. In this case, Q is both start state and the accepting state. It is the start state because before reading any input, number of zeros and the number of ones seen so far both are 0 and 0 is even. It is only accepting state because it describes exactly the condition for a sequence of zeros and ones to be in the language. That means the number of zeros is even and number of ones are even. That is what expected. So let's see the transition matrix and the transition diagram for that example. How to define that machine? That DFA can be defined with the 5 tuples, number of state Q. Here we in our interpretation we decided 4 states are there. That is what Q0, Q1, Q2, Q3. Input alphabet set is a 0, 1. Delta transition function can be shown in the transition matrix form or the transition graph. Initial state is the Q0. Final state is again gonna Q0. So our definition of a DFA look like this. Transition in this definition may be represented with the help of transition matrix or transition diagram that we already have seen. Now, say example, for this particular example, I read string 110101. After reading this portion of a part, what is the state of the machine? How could I find out? Transition function talks only about the single state and single input. I am in the Q2. Right. But now extended transition function talk about our particular string. I read these many symbols till moment, and last symbol. So first of all we will break into XA form. X is your 11010. A is what? 1. So for that sequence we are supposed to follow. So by using the rules whatever we studied till the point, so initially nothing is void. So delta transition function Q0, by default you are in the Q0 initial state. We start always from the start state, and first symbol read is a empty string. Nothing we will read. So we will be in the Q0. Now I'm in a Q0. I read first string 1. So what is the extended transition function? By using this formula we will write like this, and we will reach to the Q1. First of all, I break this as a XA. X will be the epsilon. So extended transition function for the epsilon is same state Q0, comma, now transition function Q0 after reading 1. What will the state? Q0 on 1. Here we have already shown Q0 on 1. I'm in a Q1. So we are going to write here Q1. Now suppose I read 1 1. So Q0 at 1 1. I repeat the same state. Now I will break this string as a XA form and write the equation. So it will look like this. Delta transition first we will find to the 1, which will give me the Q1, and again delta transition that Q1 on 1 will be Q0. So again we will read the next part 1 1 0. Find out the same equation by applying the same thing again and again repetitively. So we will break the string. Here we break as a XA form. X is a 1 only. Now in this case X will be 1 1 and A will be 0. In this example X will be 1 1 0. Here we return X. Till that point what was your transition state? 1 1 0 you will get from here. Q0 and 1 1 0. You are in the state Q2. We already calculated that. So Q2 on 1. It will give me the Q3. Now next thing 1 1 0 1 and 0. So I will divide this into XA form. X will be my 1 1 0 1 and input will be 0. Last symbol of a string is a 0. So what is the delta transition function for 1 1 0 1? We already calculated in step number 5. That is Q3. I'm at Q3 and now I read 0. What will be my next step? Q1. Similar last point is here we dividing the X into 1 1 0 1 0. That is my X. So delta transition till this X was Q1. So Q1 on the last symbol 1, Q1 on 1 is equal to Q0. So here as you reaches to the Q0, your string 1101 is in the accepting state. So this string belongs to the language. All of you understood this part? If you have a doubt, you can ask me.